Sometimes, an hour-long lecture is really difficult to get through when you have a teacher lecturing to the entire hour. Just getting the students to talk in the middle of class about the pertinent subjects that we're discussing in the lecture is going to be helpful in breaking up the lecture.
I think that the professors expected the students to just sort of soak it up, in a typical lecture, content delivery mode, and the students were just supposed to absorb it and be able to spit it back out again.
We know that group work is a great way to help learning. When the students are working together, they're very actively engaged, processing the material as they talk about it, and we know that's exactly what's essential for achieving good long-term learning. Group work isn't a magic bullet. It has to be done right, and there are a number of challenges to make it work well, dealing with things like organizing the groups and the kind of tasks you give them to do.
This video will show you some different examples of group work and tips for facilitating it based on research. First, we'll get a snapshot of the benefits of group work, then take a brief tour of what group work can look like. Then we'll give some key tips on facilitating group work, like choosing the members of a group and helping them work together productively. Finally, we'll talk about what kinds of tasks are best suited for group work and how to assess student learning.
When I'm not learning something or when I'm not getting something by working in the groups, I'm able to experience it through a different way and see how other people are thinking about it so that I can better understand the concept rather than just the single way that Dr. Knight explained it.
There's an enormous body of research showing how feedback, very timely, specific feedback, is the single most important contribution to learning effectively. One instructor with 30 or 50 or 200 students, you don't get that, but you can get a lot of useful feedback from your peers.
So we can look at the wavelength and say, these have the same wavelength, so they must have the same energy.
And you really get a chance to work over problems regarding these experiments with people that are close to or on your level and not a professor who's done these for 20 years before and is way above you.
It really helps reinforce the ideas in my mind to explain them to other students at my table.
There's lots of research showing that teaching other people helps one learn the material. People process the ideas in a very different way. Their brain thinks about them, structures them differently when they're confronted with the idea of teaching another human being about them. That's really why the teaching process that can occur in group work enhances learning. There are a lot of different kinds of group work. There's out-of-class study groups, in-class discussions, or in-class group activities, or you can have longer-term collaborative assignments. Most common is just to use these shorter-term in-class group work. For example, tutorials, concept mapping exercises, worksheets, labs, and more.
Here are 3 examples of these kinds of in-class techniques.
We have one activity that we do, which is to try to understand the correlation between energy and temperature. And so it's the kind of thing that you can lecture students on and they somehow don't seem to ever get. And so the way that we did it is I gave students a worksheet and they had to sit in groups and answer the questions on the worksheet. So there's always a worksheet. I asked them to break into groups of somewhere between 4 and 6. I have myself and a TA in the class and we kind of circle around the different groups and listen in to hear sort of what the conversations are.
We have some evidence for these things helping students learn, both from things I've seen in class because I eavesdrop on conversations, and I'm hearing students having conversations we want them to have.
But I mean, what other factors of our sine waves are related to energy?
We've used whiteboards to have students draw a sketch or a graph. We've had students use whiteboards to do a short derivation, one that maybe required just a little moment of insight, and it only takes a couple minutes, and sometimes it sweeps through the room. So the idea was, we are talking about a very complicated physical system. The hydrogen atom in quantum mechanics has many, many variables and quantum numbers, and the pictures in the textbook are horrendously complicated. The task was generate a picture that would represent the hydrogen atom wave function in the following simple case. We tried using notebooks instead of whiteboards, just have people write answers on a piece of paper, and I was amazed at how few students would write anything down at all. And I think I decided they don't want to risk writing something wrong in their notes. So, what we want is for them to have the freedom to write some nonsense down, to get ideas wrong and then fix them, and the whiteboard is perfectly well suited for that. Whiteboards also give me the chance to walk around the room and see people generating ideas. So that was the purpose of that whiteboard activity, was just for them to generate this representation on their own. And even if they didn't get my representation, they're ready to see it now.
In the group work in class, I like to try to have the students focus on either designing an experiment or interpreting the results of an experiment. So today in class we were talking about neuronal plasticity. So the experiment was that you close one eye early in the life of a kitten.
We were given the lecture kind of on the very basic concepts of this experiment, which is a seminal piece. It's huge in our field.
And then they were to make a prediction about what happened if you close both of the kitten's eyes early in this phase of development. And that was the part of the experiment that had a surprising outcome.
What we had to do is you have to be able to understand the basic concept, and then we had to apply it to this new parameter. And I think that what it did was it made every student walk away with a really complete understanding of the experiment.
Look to the right of that picture that you're just showing me. It's a straight vortex.